coming to the Sofia edition of our small J Prime sister conference. It's called J Professionals. To remind you everybody, it's the conference where we invite new speakers and we try to mingle them with experienced ones so that we show them that it's not so scary to speak in front of people. Fortunately, we don't have too many people, but yeah, thank you very, very much for coming in the Saturday morning instead of staying at home or enjoying the beautiful weather outside. And yeah, just a few words from me. J Prime, we have J Prime next year, as you probably would expect. It will be on 14th and 15th of May, a little bit earlier next year, but yeah, shit happens. So yeah, we are going to open the call for speakers very soon, in a couple of weeks maybe, and yeah, that's it. So our first speaker today, that's why I'm speaking in English right now. Our first speaker today is Enrique. He came all the way from the Netherlands, and he will present you a very interesting topic. As I spoke to our next speaker, it's an old topic, architecture, hexagonal architecture, but it got a very good traction in the last couple of years. So it's back to the interesting area that people are interested in and going to conferences to learn about. So Enrique, the stage is yours.
Okay. So I guess, okay. I shout a lot, so let's see if it's fine. Okay, so welcome to my presentation. As Ivan said, okay. So just a quick introduction about me. I'm actually Spanish, but I'm working in the Netherlands for the last 5 years. I've been working for a while on all this IT thing, from, let's say, the starting points with BASIC, the Delphis, Pascal, C++, all this, but mostly Java. I'm always trying to find better ways to do things. Okay, I play an architect role in my current work in my organization. I've been, as I was saying, a lot of time and with Java since 1.2 approximately. And then I remember when the Spring Framework just came up, remember the book Expert J2EE Development by Rod Johnson. And when I read it, I said, this is what I want to do the rest of my life, or at least this is the kind of technology I want to use. And lately I've written a book, okay? And this presentation is sort of the content and the, let's say, lessons learned, the feedback and everything about that book dedicated to the hexagonal architecture. So in this case, if you want to contact me, you have everything there. I guess they will just distribute the slides afterwards. So without further ado, let me just get into the content. Bit disclaimer, obviously I work for an organization, but this has nothing to do with that. This is just my personal experience and yeah, that I'm sharing with you. Okay, so I'll go through a brief introduction to how lately the role of the architects have changed in a much more specialized way. Okay, architects are no more those guys just living in the upper floors and talking about theory and all that. They go into the ground, they get into the mud these days. So that's what I call the modern software architect, as many other authors around have also called it. I will briefly introduce, as a refresher, to the layered architectures, and then I will try to convince you that you can make the hexagonal architecture work in a very easy way with very, let's say, specific heuristics and design solutions that I've come up with and that I explain throughout the presentation. So in this case, the first thing is, I think there's been a redefinition of the concept of an architect. So we are no more people that are just working on paper. We are people that are more focused towards the engineering part of the technology. So in this case, besides all the descriptions that you will find around in the internet, I think that today's an architect obviously must bridge the technical and strategy, but let's say not only with just pure theory or these abstract patterns and these kind of things, but with also practical knowledge and on-the-ground engineering. Okay, so the perfect modern architect is the one that is sitting in the intersection between those two worlds, which at some point in the past used to be completely, let's say, isolated from each other. So in this case, architecture and engineering, I think they define the new modern architect. So in this regard, what makes an architect like a mighty architect, okay, a powerful one? Well, of course, there's the typical work. It's always been there to ensure the coherence between the design and the practical implementations. Of course, because of the new engineering role, it needs to guide all the architectural foresight with that engineering view. And then, facilitate the communication. We are also coordinators, communicators with the team, because we are sort of the glue between the developers, the QA, the project managers, business owners, etc. And I think that the one that I always tell people to, let's say, take away is that architecture is always just a balance of trade-offs. There's no perfect solution. That's impossible. That doesn't exist. You will always have to just give something up for something that you want to apply. So the idea is to be a good balancer, let's say, to find that right balance between the pros and the cons of the things that you're trying to do. Okay, so having introduced a bit the new role, why I'm saying this, because now to define new architectures or to apply existing ones to, let's say, the levels where the developers can be confident that they are going to succeed, not just paper, theory, articles and all this. This modern architect most of the time deals with layered architectures. So these are the architectures. I'm mostly focused in the presentation in the typical web development. Okay, so with the, let's say, raise of the concept of the microservices and distributed components and all these kind of things. The three-layered architecture in this case is a typical one that you will find everywhere. This is where we have a presentation layer, an application layer, and then a data layer. The application layer, you might find it as a business layer, different names for that. But in general, it's the three-layer that you find in most of the applications. What is the problem with some of these layered architectures, mostly with the three-layered architecture? They are not that solid. If you remember, solid is these 5 principles, the single responsibility, open, close, blah, blah, blah. So I won't get into them because, yeah, that deserves another presentation. But you should always have a solid, let's say, inside your head when applying any type, not only this one, but any type of architecture. Why? Because if you think about the three-layer architecture, people sometimes have this fake or false confidence that they are decoupling the layers between them just because they are extracting the interface, for instance, from the application layer, and then the controller or the presentation layer just calls methods in the interface. But most of the time, these interfaces are what Martin Fowler calls the header interfaces, which is just an interface that takes the public methods of the service that have been implemented in the application layer. That's actually not an interface. Well, it is technically speaking, but it is not from a business point of view. What we want is role interfaces, because the moment the public method in the service layer changes in some way, that makes a change to the interface, and then all the ones that are relying on that interface from a theoretical business point of view will be broken. So in this case, what we need are actually role interfaces, which is that define this contract between supplier and consumer in a much more business-oriented way. Okay, so just getting into your favorite IDE of Java, right-click generate interface from an existing service, that is not an interface that is going to decouple your layers. That's very important. The second issue I see most commonly in these layered architectures is that we start to put all these easy-to-use annotations in our objects, and then that object just traverses through all the layers in our architecture. So that means that we annotate with JSON property and JSON ignore because we wanted to render the result to the UI, for instance, in the presentation layer. But we also annotate it with entity because we want, want to use JPA, okay? And then eventually we have the coupling through the object that goes throughout all layers, okay? So if you make any change to the object, because now you need an additional column or a calculated new property, then obviously that's going to impact the rest of your code, because your code will have to change in all the layers to that.
Question now or later?
You can interrupt me, yeah, no problem.
Okay, okay. But if the business says, okay, I need a new property, then you have to introduce this property.
Yeah, but we will see how next.
Okay.
Okay, so I'm trying to describe why this guy comes here to talk to us about this, and then we will see later in the code how we can move all these concerns to their specific areas so they don't couple with the rest of them. Okay.
Sorry. Can I also ask a question about this? Is this applicable for, let's say, a database entity that also has JSON ignore a JSON property, or do you mean that some object that has JSON property transfers between the layers of
The latter, yeah, definitely. Yeah. So this is about trying to, let's say, justify the non-intentional, most of the time, issues that we have with some implementations through these typical, let's say, accidental mistakes, let's call it that way. The other one is that most of the time, because we use these wonderful frameworks like Spring Framework, which it is indeed, we structure our projects using a technical approach. So we have this typical package composition where we have controllers, services, repository, helpers, whatever. That does not give you a clear view of what's going on in your application. Remember, we are here to develop applications for the business most of the time. So the business does not care what a controller, what a repository is. The business wants to, let's say, execute their business logic, and you as a developer should be aware at any moment what a certain use case, use flow, you name it, entails. If you have this kind of a structure, you need to search through all these packages and come from here to there, and then it's not, let's say, a very nice experience, and most of the time your cognitive load cannot just keep all the different details that you need to think about to just resolve a simple bug or troubleshoot anything. So in this case, the most important takeaway is that these kind of structures, and we will see next how to improve this, just hide the use cases, which is the part that you should really focus on, okay? Because that's where the value of your application and your development is. And of course, our beloved Spring provides all these annotations, so you start just saying, okay, because I want the Spring to consider this and inject it and use all the dependency injection, I just define this as a component and all that, so you end up polluting all your business logic, which should be completely isolated from technical concerns with these kinds of annotations. As I was saying before, this is sort of accidental complexity that we just add into our developments because it's very easy just to use it and everything works, but when the project grows or when you have constant changes, maintenance, all this becomes a bit of a nightmare. So how do we improve all this? There was an attempt several years ago, which was called the Clean Architecture by Dr. Bob, where this guy just mentioned a very, very simple, I would say even stupid principle, which is dependency management. The problem you have all the time with this is that you need to make sure that certain modules, layers, parts of your application do not depend on other ones. So in this case, he came up with this nice representation where we have your business logic, so your data logic at the very center of this circle, and then we have the use cases, controllers, and devices. So you can think of the blue part of as the all the frameworks, all the different technologies that even the infrastructure concerns. Then the green part, as you can see there, are just interfaces to the, let's say, the way that our application, the core of our application can work with the external world. And then what we want to protect is this, okay? This cannot be, let's say, altered, or I cannot allow my implementation to, let's say, impact this core logic, this core center of the circle, if anything around it changes. Another, for instance, typical example could be transactionality, okay? So these cross-cutting concerns, if I want to apply transactionality to my use cases, I cannot make it, let's say, rely on the fact that later I will use a Spring or any other transactional manager. So this is mainly the idea: protect the center of your development, which is your core business logic, and then anything that surrounds it just provides the technical details, but without impacting them. It's very important at the very beginning when you see this, and I made the same mistake. I thought this was, as I'm saying there, the method called direction. It is not. The arrows are they are telling you what implements what. Okay? So in this case, dependencies go inwards in the sense that this depends on this depends on this depends on this, but not the other way around. So the more you go to the center, the more you are protected that changes of the other layers will not impact you. We will see this. I mean, again, we are now not only architects but engineers, so you will see code and you will see how this works. So one evolution of the clean architecture, because it was very theoretical, was the hexagonal architecture. Okay, you may have heard about this one. There are different like variations. For instance, the onion architecture. But in general, you will find it at either the hexagonal architecture or the ports and adapter ones. In this case, the idea is very similar to the clean architecture. It's actually its foundation. It's the clean architecture, but it sort of defines more explicitly than just saying, in this case, interface adapters or whatever. So in this case, it goes to a more level of detail, saying, okay, in the center you have your domain and your use cases, and then anything that wants to interact from outside with you, therefore call a use case and then execute your logic, must be abstracted in an input port. This is just an interface. And then any dependency you have on outside systems, like for instance, the typical example where you need to call an API to fetch some information or to call a database or whatever, that's called an output port. Okay, so the idea is that you define your domain here, then you define your use cases, which are also interfaces like create user, get user, find documents for this dossier, whatever. Okay, that is defined as interfaces here, and then the use case implements them using the domain, and if it needs to fetch information or do whatever from the outside, it just requests it through the output port, which is an interface that is then implemented by adapters.
I have a question. Why do the use case implement the input port interface rather than accept it as an injection?
Why, sorry, the use case?
Why the use cases implement the input ports, which is like a very tight dependency on...
No, because in this case, let's say in the same way that the adapters, so on the left-hand side, the adapters, I know that this is sometimes confusing because you see input port and output port. So because the output port is implemented by output adapters, like the persistence and all that.
I completely agree. What I don't understand is why the use case will implement a specific input port rather than have something like a mediator between them.
Okay. Yeah, you went ahead my presentation. Okay, so yeah, we will see. I'm using a command bus to do that as a mediator because there are different. This is like at a very high level, okay. And the idea is that there is something that implements this, and from a, let's say, logical or conceptual point of view, that's the concept of a use case or a user flow. Or I mean, people name it in different ways, but this is. If you don't like the use case wording, that's fine. This is what implements the logic, in this case the orchestration logic, that entails the input port that any external consumer calls in order to execute your business logic. You will see it, I think, better next, because this is like a...
If I may ask one more question.
Yes.
Because, you've mentioned previously, for instance, the transaction management, and you said you cannot rely on the cross-cutting microservices Spring. For instance, you cannot annotate your service metrics with transactional, because this will tie your business logic to only Spring framework. How do you do it? So you have a pure service and then adapters for different frameworks, or what is the idea?
Okay. I like those questions because you're already getting ahead of me. You will see that next. I will explain it. Yeah, because that is exactly the same questions I had when I started this. Because I went to this diagram and I said, and what now? So that's the, let's say, one of the reasons why I think this architecture has not been adopted as much as it could, because it's very nice on paper, but then how do you do this? Okay, we will see it next, don't worry, and to the, let's say, a very good level of detail. So, just very quickly, what the questions are about. Okay, Enrique, this is very fine, but how do we do it? Okay? So paper eats everything, and I want real stuff, okay? Real meat on the bone. So to do this, we need to also to understand some of the common pitfalls that I found through personal experience, and also by checking what the people outside have done. Okay, so we have most of the time when we see this kind of architectures, we go strictly, okay, everything of this is set on stone. If the, I don't know, if the theory says that I need to do it in this way, I have to do it in that way, and there's no other alternative. These kind of things, the misinterpretation of principles, they always lead to failures in the implementation or the applications of certain architectures. And I believe this is one of the cases. So I'm here, hopefully, to try to make you see that we can implement this, and we can do all the transactional thing and all that in a way that we don't couple our applications, so we get a final result that is completely isolated from the core business logic, from the technical concerns of framework, infrastructure, etc. So, what is the solution, or how can we then apply properly and succeed in implementing this hexagonal architecture? I've come up with a series of concrete design decisions that I will now explain in detail, and then I will show you code so you can see exactly how this works. So the first one is the always valid model. One of the issues that we have also in layered architectures is that we keep validating and doing this if different to null, if this is null, and these kind of things in all the layers, because we are not sure where our object is actually valid. So just in case, we take this defensive approach, which is every time that we check an object, we check whether this property is null, these kind of things. If we take this principle, which we will see with code, don't worry, then we make sure that from the moment we get a command or a query, okay, and we will see it next as well, everything is valid, so you don't have to be worrying about that. So we are already improving, let's say, the confidence in our application. The second one is, this is very controversial, I know, but I don't use exceptions anymore, because exceptions, there's a lot of explanation behind this. I don't have the time, but basically are a goto mechanism in Java, okay? Because even not a goto mechanism, because sometimes you don't even know where you're gonna catch that exception. So eventually what I've done all the time is I try to create my hierarchy of exceptions, and then if any exception leaks, don't worry. I'll go to my REST controller advice in Spring Boot, and then I'll capture and I'll just show sort of a generic error message to my user. So in this case, if we type if we change in this case the exceptions to real error values which have business mean, then you will see that we can make a better job. The other one is the either monad. So I went to the functional world, which in Java is not that common, it's more imperative. I just borrowed this concept of the either monad, which is just simply speaking a wrapper that can either be something left or something right. In my case, it can either be an error or a valid result or the empty result, which is success. We will see it next. Then I also decided to, the question about the use cases, to implement my input ports, which are the interfaces to the different actions that, let's say, a user can perform with command queries, okay, using a command query bus. So those use cases that you saw in the previous diagram, they become dynamic handler implementations in my code, okay? Or at least the routing, the dispatching of those commands and query is done dynamically, and you will see now next how I do it using the Spring application context, so I can easily determine if you're using this query, then I know I have to execute this handler because this handler has been registered as a, let's say, a class that can handle that type of queries, and the same with commands. We will see examples next. Another important decision is what I was saying. I mean, you don't want objects to, let's say, be having annotations here and there. So what I do is we have, let's say, from the beginning, from the REST layer in this case, we have request and response objects. Then we have command and queries. Those are the ones that get into the core of the application. And then whenever I need to return data back to the web layer, or I need to request additional data and then get that additional data from external systems, I always do it with DTOs. So DTOs are the only ones that are allowed to traverse the whole set of layers because they are plain old Java objects without any annotation, okay? So in the question that you were asking, the JSON property and all that, how do you do this? Because I, let's say, transport all my data just with plain DTOs, and only when that data arrives to the REST layer, there is where I define my response object. I annotate them with whatever JSON properties annotation I want, and I just map them, okay?
How does it affect the performance, like all those validations and the DTO?
I mean, if you have a, let's say, cryptocurrency real stock market application, it will affect. But here we're talking more about enterprise applications, so the typical that you develop for your business. So in this case, it's negligible because for this you can use frameworks like Mapstruct, which are very, very optimized to do this. So it's.
Okay.
Do you use records instead of Java classes for DTOs?
Yes.
Okay.
I will show it next.
Okay.
Okay. Another thing that you should leverage is domain-driven design. This is a completely topic that we would need like several sessions for this, but if you can get into it, you don't need to go to the aggregate level and identify, I mean, all the different details of DDD, but at least use an ubiquitous language, and we will see how to also embrace this in the example. I make heavy use of what I call technology agnostic annotations, which is basically creating my own annotations as stereotypes or as markers for certain semantics of my components. For instance, if I'm going to implement an adapter, that implements an output port, for instance. So the output port has an annotation, the adapter has the annotation adapter, and with that later we will see, I can use tools like ArcUnit to validate my architecture. So I can make sure that an output port is only implemented by something that is an adapter and nothing else, okay? So this is, and then also all the annotations allow me later with Spring Boot to do a component scan and register them as beans without them knowing that they are going to be registered in Spring. Because, and then with that I can swiftly switch, I can easily switch, for instance, from Spring to, I don't know, Quarkus, Micronaut, whatever, because eventually they are just plain annotations, okay? We will see it in code. This I will get into details, but basically this structure is just, is no more technical structure, is business, in this case hexagonal architecture structure where you will see the different elements. This module has, yeah, the use cases, implementations, because I can see here that this is the input ports, this is the application, handlers, etc., etc. And then, of course, in my case, I mostly work with the Spring ecosystem, so I use the dependency injection from Spring Boot to assemble this all, okay? I know you have a lot of questions, but let me just go through this so you get the idea, then you will see the code. In fact, you will start seeing code now. So the always valid model, what is this? This is basically making valid state unrepresentable. If I can make sure that the moment I get a request from my web layer, that turns into a command and query that is already valid, I don't need to be checking for null, checking if the object is within a range, all these kind of things anymore, okay? Because I know that from this moment onwards, that object is valid, and the same for the objects in the domain model. So, if I make this a bit bigger, the idea is the following. In this case, I didn't use records, just because records do not have yet a mechanism to, let's say, stop the creation of the project without throwing an exception. So in my case, I told you I'm not using exceptions, so I'm just using error values. And what I do is I leverage the Lombok, in this case, library, because one of the things that I forgot to mention is within the implementation, you need to agree with your team which libraries are not the pure JDK, but still you allow them to be part of the core of your application, which is the domain and the implementation of the use cases. In my case, those libraries are Lombok, MapStruct, and the one that you could see here, Vavar, which is the functional implementation of the either monad. Okay? So those three, I allow them because I consider them like core libraries that are not going to be replaced with something else, like could be a different database technology or framework or whatever. So in this case, if you can see, what I do is I have an author, and then the only way I can create this author, because I have this, is by calling the static factory method. There's no way I can create an author without it being a valid author in my domain, which is it must have an ID and a name. You may also notice that I'm using a lot of typing here because I want my, let's say, business entities to be, let's say, strongly typed through the use of value objects, okay? I don't want to use final long ID because what's a long? Is it 1? Is it 2 million? But the worst case is a string, okay? I don't want name to be a string. A string can be 1, and 1 is not a valid name. So I type them, and I make sure then when I validate the other ones, this is obviously a hierarchy of validations, that all the time those are fine. So in this case, every time I create an author, the person name I will get will have been previously validated, and it will be a valid name with whatever the business rules that I want to have for my name, for my author ID, etc., etc. So this is a very, very important principle. You don't apply this to DTOs, okay? Because in the case of DTOs, it's just data that you get from outside, unless you have a strict need. But at least you should only apply it in common queries and your domain entities, okay? The next principle is error values over exceptions. This is something shocking. I understand that because we've been so used to just working with exceptions in Java. I cannot get into the details, but if you go to the official documentation, you will read from Oracle that exceptions are for exceptional cases. The fact that I request an author and it's not there is not an exceptional case, unless obviously it's a server issue and all that. But in any case, that's even not exceptional because you know that we have these 12, I believe, network fallacies that your services will always be running, the network will always work, and this kind of things. So if I cannot get the author, that's a business case. It's not available, it's not found, has not yet been created, whatever. So in this case, I want to model this a real business value. And for me, the real business value is doing it, and then this goes to another question I got previously. This is where I embrace all the new features from Java 14, 17, and 21. Where I use all this sealed interface and all that. This is known in Java now like the new data-driven programming, okay? But in a nutshell, this allows me to generate hierarchies of errors that then I can come to a construct like this and then do the pattern matching, which is I cannot, let's say, compile this code if I do not provide absolutely one entry for each type of error. So with this I get for free compilation time validation that I'm handling all the errors. This you cannot achieve with exceptions, and if anyone knows how to do that, please contact me later. Okay, so I have a very clear way, and another advantage of this is who needs documentation? Do I need to create a 10 pages narrative for this? No, it's clear, right? I have validation errors. Well, there is a method that goes into the different details. I have the possibility also to create multiple exceptions, multiple errors. Then I always differentiate into business error and technical errors. So, yeah.
Yeah, so previously you mentioned the solid blah blah thingy, and the second principle called the open close principle says that your application should be open for extension, both for modification. But in the narrative here, you make your application open for modifications because if you need to add a new error or new error handling, you have to add it in the switch case here or in the static factory of the entity of the DTO. So if you use, for instance, Spring Framework, which is a concrete implementation, you can distribute this by some annotations and actually decouple it. But now it's not. So do you think if you create your own mini framework to do all this cross-cutting concerns, will be good, or you prefer this violation of the open close principle?
This is the perfect example of one of the principles I mentioned at the beginning. Architecture is a balance of trade-offs. So in this case, I accept breaking this principle specifically because the advantages I get, I think they are more than worth of doing it. So instead of doing one of the approaches, as you mentioned, I prefer to do this because this I get it directly from the JDK and I get it at compilation time. And then also the IDE, for instance, I can show it later if time allows, but if I remove one of them, the IDE will complain automatically, it will do autocomplete for me. So for me it's easier to represent it in that way. It's more also readable even for non-technical users to understand, okay, you have all these kind of errors, rather than getting into sort of a solution based on something that in this case fulfills better the open-close principle.
Yeah, you can create some annotation processing that actually creates the very same code, but it's driven by annotations and not by developer cases here. So you will also have the compilation error after the annotation.
Yeah, of course. I mean, there are different approaches. This is just, so as I was saying, there are different ways you can implement these architectures. This is one that if you follow these guidelines, and of course, I mean, then you can tweak it or you can even cherry pick different things to apply it in different architectures. If you like this error value driven approach, you can say, well, I like what Enrique told me the other day, I'm going to apply it in my 3 layers. I mean, it's not specific, but in this case, yeah, I wanted to make it as, let's say, as simple and stupid as possible. So if you make an error or if you do something that it's intentional because you agreed to do it. Okay, so the third one is the either monad. This is from functional programming. As I told you, it's just a wrapper that tells you, it's like the optional in Java, and it has a left and a right. The right, because in English right is right, correct, then is the correct, and the left is the not correct. So I'm using error values, but you could use exceptions if you want, okay? You could use an either of an exception and then whatever, but in this case I also wanted to combine with the fact that I don't want to use exceptions, and we will see next, because you may be wondering how this guy manages to not leak an exception. We will see it, it's extremely easy with another keyword from this library, which is called the try, okay? If you're familiar with Bavar. So in this case, commands, very important, CQS, command query separation. Commands should not return, actually must not return any value, okay? And queries can obviously return, because queries do not have side effects, whereas commands have. This is also controversial, and we can discuss it offline later. how then you manage the typical cases where you create a user and the database returns you the ID. And you cannot return that ID anymore, okay? But let's not get into that in this presentation. Then, so I implement what I called in the previous diagram the use cases with a command and query bus. So as I told you, and we will see, there is a request coming, I create a command or a query, and then I send it to the bus. And then the bus figures out which handler to execute, because I have defined that this handler, which is just a service class, implements the logic that is associated with a request coming from either this command or this query. We will see it in code, and you will get it, but basically it's just a couple of interfaces that you need to implement, in this case in your handlers, in the, let's say, what you can call also the application services. And then, as you can see, they are strongly typed, so in this case, you can only call the query handler using a query for obvious reasons, and then a specific query, because I'm also using generics, and a command with a command, as it is obvious. The good thing about this is that we can, if you think about it, we can add a lot of pre-process, or let's say wrapping concerns around it. For instance, I could create very easily a small wrapper that on each execution of a command just logs the time it takes to execute. So sort of a small profiler performance thingy, okay? Or I can apply security concerns, or I can apply transactional concerns, and these kind of things. So you start to see, let's say, a small spoiler on how then we can do certain things, but we will get into the details now. Then the other one was DTOs, okay? So DTOs are the only ones that in the architecture, they are used mostly to either request data to external parties. So if you are in your domain, you basically create a DTO with the input data to that external service, let's call it an API, and then when you get the response back, you also wrap it, model it, map it into a DTO.
And just one question, maybe Michael, but in your practice, are you using immutability for DTOs?
Yes. They are value objects. Yes.
Okay.
Yes. And this is the important part. The important thing is that, and I got a question before, I mean, this may introduce additional overhead in the application. The thing is, actually it doesn't. I mean, in a regular enterprise application, not a real-time stock market or gambling application. So in this kind of applications, which are the ones that are the focus of this presentation, these are the different object models that we have. As I've been mentioning, we have request response models, which only are available to the controller. Here is where we can use the JSON property, the JSON, whatever we want, because these are the ones that eventually are going to render my responses to JSON, to the UI, for instance. Then those over there are specific objects that I need to work because of the details of the API. Those are DTOs, okay? And then in the middle, the domain model is something which is not a DTO, is let's say in terms of DDD, would be my entity, my value object, my aggregate, whatever. But in any case, are objects that are not polluted with any annotation, technical annotation, okay? Like the JPAs, the JSONs, or whatever. And then to get here, we need either a command of a query, and as I mentioned, if I need to, let's say, call an external one, then I use DTOs. And then the response that I get maybe from that adapter is a DTO, which is immutable, a value object, and then gets back here and here. Okay? Every time you see these things is that we need a mapper to be mapping between objects. Again, with map struct, this is a kid's game, it's a breeze, because you just define it, and most of the time the objects will share commonalities. Okay? But at least if you change, for instance, one of the objects of any adapter or to the right, let's say outside of the domain model, your domain model will never change, and then you can put specific annotations to the specific layers where you are allowed to do that. Okay, we'll go very fast here. One important thing is you have probably heard about this principle of this anemic domain model. The anemic domain model is just creating plain old Java objects with no behavior. If you go to the roots of not Java, of object-oriented programming, an object is something that has a state and behavior. So we lost the behavior in our way somehow. So what domain-driven design embraces is get back to putting behavior in your classes. It's not a problem if you have an article and you have methods on that article, because it's the only way you can control that that article does not go into an invalid state or does something that it shouldn't. Okay, so in this case, this rich model, data-driven approach is what is encouraged in these cases. And as I was saying before, and this starts to answer some of the questions I got at the beginning, there is this technology agnostic annotations, as I call them. Some of them act as cross-cutting concerns markers or boundaries, like the transactional, whereas other ones work as stereotypes for the different elements, components that I have in the architecture. So in this case, every time I implement, I define a use case in the sense of the interface, the input port, I annotate it with that. The handlers, I annotate it with application service. The adapter with adapter. Why I do this? Because then later with ArcUnit, I can validate your architecture. I will make sure that you don't, for instance, I don't see any org Spring Framework dot whatever as an import in something that is a domain service. That is strictly prohibited. So in this case, I can check that with this tool. Okay? All of these, you have the code in my GitHub, you have examples, the reference application that we will see immediately. So you can see exactly how this, let's say, allows me or your application to be tested from the architectural point of view, which is an angle that not all the projects test in this case. And then I will skip this quickly because we are going to see it in code, but you will see that now the structure that I was mentioning before is now driven by technical concerns, it's driven by the elements that you have in your architecture, and you can immediately see that if you you have been contacted that there is a bug in the creation of a user, you know exactly that the use case is defined here, the application is defined here, the dependency is defined here, these kind of things. And as we will see next, using the same naming convention, so it's very easy just to type it in your favorite IDE and then get the create user request, create user command, create user handler, create user use case, create user output port. Everything is boring because it's always the same, and it's really, I mean, the IDE will show all the things that you need to have in your head, which is good for your cognitive load, immediately there. That's why I call, and some authors call that this is a screaming architecture, because immediately you can see what's going on. We will see now in code. And then last but not least, the most important part, in terms of, okay, now you have lots of different classes around, there's no technology, you have annotation, but what happens when I want to execute this application, because this needs to be executed eventually. This is how the magic sort of happens, okay? So, if you're familiar with this annotation, with this in Spring, and the same for the different frameworks, you can tell the dependency injection of a Spring to detect any class that has been annotated with any of those annotations and then register them as beans. Why would we do this? Because if they are registered as beans, they can be injected between them, right? So if my application service requires an output port, which is a specific implementation, then at runtime, Spring will go there and say, okay, you have everything, well, you have this class annotated with application service. That means this is a bean for me. Then it will find the adapter class, which is the implementation of that certain output port. This is another bean. If I have two beans and you are telling me that I need to auto-wire it, in this case through constructor. I'm not using most of the time add auto-wire, but just constructor injection, because then it's easier to test and all this. Then everything will be assembled and you will have everything together in your application, as we will see next. And the other part is just some, let's say, scaffolding or plumbing code, as I like to call it, which is instantiating the command bus as a Spring command bus, and this is the same concept. This is just detecting the classes that are annotated with certain annotations, and then checking which command, which query do they use, and then making the relationship between the command and the query and the handler that uses and applies that command query, as we will see next in the code. And for the transactionality, if I have this completely technology agnostic annotation, which is add transactional, and then I add any transactional manager from Spring, like the regular one, the platform transaction manager, which is in the module Spring TX, then immediately, just by adding, in this case, this is just for properties, but yeah, what I wanted to say is that in this same code, if I just add that annotation, immediately Spring will detect there is a dependency that has a transaction manager, and then I have some, in the library that I provide also with the code, I have some sort of magic code, which is as simple as registering sort of an interceptor for any transactional call that comes from my own annotation. And that is the way I can apply transactionality without having to use the add transactional of a Spring explicitly in all my core domain logic. Okay? So it's sort of what you were saying before, but applied to the level of the transactionality.
Yeah, but nothing stops you to not implement the transactional management. So you can be left with the annotation transactional be there, but nothing to implement it.
Of course, of course, of course.
Nobody will tell you, nothing will tell that error for you.
Exactly, exactly.
Can you add this to ArcUnit to say you need implementation?
That is, exactly, exactly. So ArcUnit is sort of your guardian to make sure that you don't forget any of these things.
I hope you say some words about the testability of those.
Next slide. I'm fast. So, guards against and accidental mistakes, okay? Because at the beginning, this is like, well, there are like 7, 8 things that this guy is telling us. Okay, embrace ArcUnit for all these things, to make sure that you don't forget to implement this, that you are not actually using framework technologies. It's very easy to do because ArcUnit allows you to say, okay, my package or classes in my package are only allowed to depend on classes on these packages. And you say, the JavaX package, the Lombok package, this package, the other package, and then you're done, okay? And then, I'm almost in 15 minutes, so unit testing, okay? This deserves another complete, but I wanted just to give you sort of an initial feeling, because everything is so well identified, because we have these stereotype annotations, because we do always everything in the same way, now we can extract what I call these typologies for unit testing, because most of the time you'll be checking these kind of things, okay? Okay. Yeah, okay. Okay, you'll be checking these kind of things, static testing, static factory methods, all this, okay? So you can, the moment you do one example of one of these, it's just a matter of copying, pasting, and then adapting to the specific needs. Because you always do the things the same way. You don't reinvent the wheel anytime, okay? So there is a reference, if I have 5 more minutes, just for a very quick execution, so you can see how the code assembles together and everything. There is also a reference application that you can see in action, where or use it as a playground just to see whether you get this or whether you can answer some of the questions that for time constraints I may not be able to answer. So let me just come here very quickly in 5 minutes. So here, this is what I call the screaming architecture. Why? Because in this case you can see that your application is obviously about, but when I extend this, okay, is about, and then I come here, and then I say, in the application core, I have the input ports, okay? So if I come here, I can easily, in any application I do in my life with this architecture, the definition of the use case, the input ports interfaces will be here. So can anyone tell me in a first sight what my application does?
Yes.
Okay, creates articles, delete articles, blah, blah. If I had the typical controller service and all this with services that execute different use cases because this piece of code is very similar to this, so I group them, and this does not work, okay? This is very explicit and screaming at you what I'm doing. If I take the create article use case, then I go to application. Wow, create article use case, create article handler. And let me just remove this. And in this case, this implements, see, it's always the same. I mean, where do I have it there? A create article handler implements the use case with create article as prefix all the time. Then it requires a database and some external API to fetch the details of authors, okay? But this is me, let's say, going too far. At this point, I don't know what the author port is. I don't know whether that's an external service, I don't know. I don't care, because this is my core logic. I know that I need someone, I need help to fetch information about authors. How? I don't care. Someone will tell me how to do it at runtime. And the same for the article repository, okay? This is a much better known pattern, which is that then you can, in theory, plug different databases and all that, but the idea is that one. And then here, in this case, I have it commented out because for this very simple implementation, it's an in-memory repository, just to not get into all the hassle with JDBC and all that. I wanted to make it very simple, but this is where the transactional would kick in, okay? And then later, Spring would assemble everything, detect this transactional, and in the helper code that I bring through a Maven dependency, will tell Spring, every time you find this, this is the demarcation of a transaction. So start one, and then commit or rollback or whatever. I have the either error. So this either returns a success, because in this case it's a command, I cannot return anything, or an error from my hierarchy of errors. And the handler only does orchestration, which is to create an author, I need to look up the author, then map it to an article together with the request I get from the command, and then save it into the database. At the beginning, I understand it's a bit weird to see all these boxing and unboxing, okay? Like the optional type in Java. But again, this is one of the trade-offs of using these kind of monads, but it's worth it, okay? Once you get used it, it's a very fluent API, it's very similar to the Stream API in a regard, and it's really convenient.
Yeah, I know we don't have much time, but is that complying the same level of abstraction? So for finding an order, you're sending to output port, because another command will do it. But for saving, you're doing it through the repository. Shouldn't there be another layer that adapts these both things, makes the finding, sends then a command to save, and another handler just saves? Not use repository and output code in the same class.
As I was saying, the handler is the orchestrator of the use case. So that sometimes is just one step, just calling something and returning. So it's just a proxy that fetches information, aggregates it somehow, and returns it. But if you need several steps, it's fine. I mean, the problem gets when you, let's say, see 10 output ports there. Okay? If you see 10 output ports, then you're probably breaking the first S in solid, because your handler is doing too much. Okay? But having like 2-3 output ports combined with a repository, that's fine. If you think about it, is what do I need to create a user? I need to get the author in this case. I need to, the article. I need to get details from the author and then save it into the database.
How are QNIT will prevent us from doing this defined by ID instead of using the output port.
No, but I want to do both. I'm not sure if I get
Then
it.
if I don't use the output port but use the repository to look up the author,
Okay, yeah. I mean, ArcUnit goes to a certain level. It cannot do, let's say, in that regard, certain things. I mean, you can probably do it, but not with the, let's say, standard artifacts that it allows you. I mean, that would maybe require to do some static analysis to your code or something like that, but that's not the purpose of ArcUnit. ArcUnit is more at the, let's say, more, the architecture. So in this case, for instance, if I had there a dependency which is, let's say, another handler, a handler cannot call a handler. So in this case, that I could capture. But I see your point. And one of the problems that eventually is just matureness of the developer is that you don't end up with literally creating an output port and then does everything for you. So you're moving the problem from one layer to the other one, okay? But at least with this you have clear guidelines to be able to do it. So if I execute this very, very quickly, okay? I can do, for instance, the typical, I cannot make it bigger, or I don't know how to do it. So in this case we can do, okay, let's create an article which is just a post of JSON. Okay, and then if I click send, then we can see here what happens. We got it in the let's say API layer, which is just the typical REST controller layer for a Spring. Notice that I'm using a specific article request object. Okay, I'm not using a map, or I'm trying to type everything because I want to have control of everything. Notice that I create a command through the validate, then create. I'm not using a new and then forgetting to set some property and then getting a null pointer exception later. Once I do this, okay, then I convert it to an either. This is just what I was saying, one of the trade-offs. We need to be boxing and boxing, boxing and boxing. But it doesn't affect performance. In this case, what I do is what I told you. I don't know which handler will handle that. That I have defined in my code by extending this interface, doing this, doing that. I just put it in the bus and let it execute. That's all. Okay? So how it works then? Well, because I have this Spring implementation of the command query bus, this figured out that in order to manage a create article command, there is a handler which happens to be named as create article handle, that is the implementation of that use case, blah, 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 and it performs that logic. In this case, it calls an external output port. Which is that implementation? Well, this one. Imagine that this, pretend, okay, that this would be a call to an external API with, all the things that we can do with, by the way, I strongly recommend you to use the new REST client instead of the web client, but this is, I need to update this, and pretend that this is a call to an external API and returns that author. That goes there, then save it, just 1 second, I complete the, okay? And then, remember that I told you, how do you do then to make sure that you don't leak any exceptions? There is this wonderful construct, try. If you wrap anything around a try off, any exception that is thrown between those boundaries will be caught with this map left. And then what I do is, in this case it's a very simple example, so I just say something went wrong, but it's a technical issue, but it's my error value. It's not a whatever exception this API may throw, or whatever. What I typically do here is I have a more elaborated method that looks for, is it a 404, then is a, I didn't find this, is it a 400, your request was not valid, these kind of things, okay? But I always translate it to error values, and then I do that extra map just because a command cannot return anything, so I'm just saying everything went okay, just go on. If everything goes fine, then we return to the controller with what? In this case, with a void. If it had it been a query, it would be a DTO. But in this case, I can show it quickly. So for instance, in the case of a query like this one, see, I would get an article DTO, and I also put it there because let's say all the plumbing around needs to know specifically what to expect and all this, and then I just either with this one, if it's an error, I create a failure, if not, a success response, and it's always the same. My code is boring now, okay, because it always does the same. The only thing that really changes are the handlers somehow, and the adapters, of course. The adapters are the free world for you, okay? So then I just execute it, and you get a 201, so now when I change it to get, then obviously I get the result that I have just created, okay? And yeah, that completes
If you execute it once again,
the post.
yeah.
This is a reference application to show the purpose of the architecture, not as a real, let's say, value. It will work most probably, right? Let's check just for fun.
There is no check for existing keys. So.
Yeah, of course. I mean, this is just a map. Okay, so so I'm not sure if yeah, I ate a lot of time, but yeah, if we allow questions, just
Yeah, my question was in the reference applications, the place where you query for the author.
in the reference, sorry.
In the reference run that you did, the place where you query for the one of the parameters that I needed. Of course, this was stubbed there, and when you use stubbing, usually it's a synchronous action. How do you deal with the synchronicity that's usually involved in this? So you have a command, you gather the parameters, you figure out that you have to hit some IO to get additional context. But this is asynchronous. How do you deal with in your architecture?
Very quickly, because that's, again, this helps another one, but within the mostly domain-driven design, but not necessarily applying strictly, you have this difference between domain events and application events. So sometimes, for instance, I want that every time that I create an article, I don't know, you send an email to the author or to the subscribers to let them know there is an article from this author, okay? Which would be some sort of asynchronous. In this case, what you do is in the create article, your domain has a list of events that are just piled up by the handler. Once the use case is done, the handler is done, then it just tells an output port, in this case, which is a publisher output port, go publish all this. If they are domain events, then my implementation or the way I do it is through the Spring application event context, okay? Where I can then create a new input adapter that is a listener to that event, and then the moment I get that event, it triggers my listener, and then it's exactly the same flow. It's an input, let's say, input adapter, instead of being REST, is a Spring event that creates a command that calls a use case, which is the implementation of a handler, and does everything. In the case of application events, or external events, I want to emit an event because I know that there are third-party systems around that are interested in knowing what happens. Then for that, I would use an output port, which I can implement, let's say, with Kafka. Then I publish it, and I forget. So in this case, it would be different. Okay, but it's always the same.
I have a...
Okay, I'm afraid that...
Let's discuss offline, no
our
problem.
time is up, so Enrique will be around for the next...
Yeah, and I could be talking all the time. I don't want to jeopardize your event.
So thank you very much, Enrique.
Thank you.
Very much for being here.